For the first time ever, scientists have been able to steer nanorobots through dense tissue prevalent inside the vitreous of the eye. So far, these so-called nanopropellers were only able to travel through models or fluids, but not through real tissue. With this, science is one step further towards nanorobots becoming minimally invasive tools for precisely delivering medicine to where it is needed.
So the vision of these nanopropeller is that one day we will load drugs and they will carry these drugs and propel through the vitreous to the retina and release drug very locally in a targeted way.
Dr. Tian Chu and his colleagues tested the robots on a dissected pig's eye at the eye hospital in Tübingen, their collaboration partner. Developing the nanorobot with its special features was done at the Max Planck Institute for Intelligent Systems in Stuttgart.
So here is actually a model of our nanopropeller. It has a spherical head and a helical tail. The helical tail is the important part because when it rotates, it will translate this rotation to forward propulsion.
For the Stuttgart scientists, this is not the first nanorobot they have developed. For several years now, they have been creating different types of nanorobots using a sophisticated 3D manufacturing process developed by the Micro, Nano and Molecular Systems lab. They build their nanorobots carrying tiny particles of magnetic material, such as iron, so they can be steered magnetically. But this time, they also needed to add a special coating. A difficult task, given that the nanorobot is 200 times smaller than a human hair is wide.
The coating is very important and was developed by Jiguan Wu, who was a Humboldt Fellow in the lab, and it consists of two layers. There's first a solid layer, which is chemically bound, followed by a liquid oil layer, which really minimizes the adhesion to the biological network in the eye so that the propellers can move.
The coating is inspired by nature. It is like the slippery layer found on the carnivorous pitcher plant to catch insects. This Teflon-like coating is crucial for the efficient propulsion of the robots inside the eye. It minimizes the adhesion between the tight molecule mesh in the vitreous and the surface of the nanorobots. That way, the robots don't damage the sensitive biological tissue around them.
So we inject these nanopropellers with a non-magnetic needle into the eye in the center of the vitreous, and then we start a magnetic field to propel them towards the retina.
Now that it is possible to magnetically steer nanorobots through an eye towards the retina, perhaps one day they could release drugs in this difficult-to-reach area. They could become minimally invasive tools for targeted drug delivery. It's still a vision, but the scientists are working hard to soon make this a reality.